Now, how many times has something like this ever happened to you? You just got to the office and you're already tired. You got stuck in traffic because you woke up late, and it's just not that great of a start to your morning. You have one of those early morning meetings, you know, the ones that should have been an email. You can't do it without coffee. In my case, sugar-free Red Bull. 7 minutes, you can make it, right? Drop your stuff, go off, grab your coffee, come back, try to log in, and you can't. Okay, try to log into Outlook, and you can't. Maybe I just missed one of those password expiry mails, right? So you go to reset your password, and you get greeted with a message. This account has been deactivated. Please contact your administrator. Now, this is your client's account. And you know the contract's going to renew in 2 weeks, but they just need to sort some stuff out and sign some things. So according to their system, it expires in 2 weeks. So logically, they deactivate you now, right? So now you're stuck in this limbo state where you can't log a ticket to get reactivated, but you can't get reactivated without a ticket. Okay, this has definitely happened to someone else before. It was a mission. They mentioned it in this one meeting, and there was a PDF floating around. There were a bunch of hoops to jump through, because we all know the easiest thing in the world is getting access sorted at the client, right? So now you got to call David, who's going to call Julia, who's going to call Hendrik, who's definitely going to send a link to a Confluence page, which you can't access because you don't have access. What if you didn't need to call David? Well, you'd still have to call him because of, but anyways, what if you didn't need to call David? What if you could just search a question in plain English and get your answer in plain English, accompanied by that meeting recording at the exact spot where it was mentioned. And on top of that, the PDF with the steps you need to follow highlighted for you. What if it didn't need to be that much of a headache? Hi, I'm Tiané Erwee, software engineer at BBD since 2018. Front-end dev by day, Seeka dev by night. Now, I wanted to be an artist, believe it or not, a painter. But my very intelligent mom told me to study something that'll lead to a financially viable career. Something like engineering. Fine, she has a point. What kind of engineering? I don't know. I don't want to be an engineer. So in 2012, I started studying aeronautical engineering at the University of the Witwatersrand. I didn't even bother scrolling past A. But I got bored. Luckily, I go to my mom and she tells me about this degree called game design. Appealing, right? Crossover between art and engineering. So I switched over to game design engineering. But engineering really is not my vibe, so I got bored. Luckily, there are 2 parts to the game design degree, engineering and art. So I could drop all the subjects I didn't care about and pick up stuff more suited to me, like animation and data visualization. And that's what I now have my degree in. I have my honors in the Bachelor of Arts in Performing and Visual Arts, specializing in digital arts. Game design. In my final year, I got an interview with BBD. So back to my mom, hey, what do you think about this company? And she tells me, BB&D, because the and wasn't always silent, is a really good company to work for. They really take care of their people. So I took the interview, I took the job as a software engineer. I guess she was right all along. So I started out building front ends for one of the big banks. I actually started with WebSphere, which might explain my strong feelings towards Java. But soon thereafter, I started building Angular front ends, and that's what I've been doing since then on many projects, with some Node.js backends sprinkled in between. But then I got bored. I wanted to do something new, something I wasn't used to, something completely different. So I took a hard right and ended up in the data science team. And from there, Seeka. Apologies. Now, when I joined Seeka, it was only a demo. But we had big dreams. We wanted a crawler to grab all of the data, but we also wanted a processing pipeline and then also some machine learning models on top to enhance the data and make it better. And all of that we wanted to smash into Elasticsearch with some neat APIs, wrapping it all up. Basically, we wanted to build a modular system where each of the parts work independently, but seamlessly when used together. Our exact words in that room were that we wanted to build it like Lego. Now, if you know me, you know there are two things that get me super excited: Formula One and Lego. Now, you gotta understand how excited I was when this baby was released. So clearly we bought it. And while we were building it, we were watching air crash investigations, because nothing says relaxing Sunday like fire and destruction, right? So here's the scene. We're sitting on the floor, going through a whole bunch of blue and black connector pieces, when this comes on in the background.
You flew jump seat from Dayton, right?
Yes, sir.
What was the holdup?
The windshield.
That took what? 5 hours? That'll mess up a day.
Either they just stuck it on with crazy glue.
At least my side would be fine.
Well, that's all that matters then.
Captain Kevin Staples is preparing to pilot Emory Worldwide Flight 17. His first officer.
True story. Actually, fun fact, okay, this is one of the 7 episodes I've seen where the crash is not pilot error, so let's hope that means something. Anyways, so now I'm sitting there and I'm thinking about work for obvious reasons. And I think back to that day when we said we want to build it like Lego. We didn't just build it like Lego. We built it like this Lego. We built it like this Lego McLaren. There are 4 main parts to Seeka. Acquisition. This is where we go out and grab up all of that good raw data. Processing. This is where we take the raw data and make it usable. Enhance. This is when we take the process data and make it even better. And search, which is, well, search. We search across the data. Cool, I get that, but how is this like a car? Acquisition is like the differential of the Lego McLaren. We need something to get the wheels of this whole process turning. First, you decide where you want to grab all of your data from. Then you provide us with a configuration file. Then we go out and we grab the context of all the web pages and we write those to file. And we download any documents we come across and videos. Then we split that out into neatly separated folders, topped off with a log of the acquisition itself. No special setup required, just one configuration file. Cool, I get that. But how's this like a Lego McLaren? This is the differential from the McLaren. Now, this isn't my first Technic build. And this is the differential from this Porsche. And this is the differential from this Ferrari. Now, as you can see, these are all, in fact, identical. And that is what the acquisition engine is to you. It does not matter if you're building a McLaren, a Porsche, or a Ferrari. This can work for you. No special setup required, just one configuration file. If you want a list of all the dead pages on your website, you got it. If you want to download all the documents in the disparate repository, cool, no problem. If you want to scrape the LinkedIn profiles of every employee and see who's actually sharing those recruitment posts, you might want to keep that one to yourself, but it's possible. Now, if you have built a Technic car before, you know that the engine has functioning pistons. And for that to work, they all need to move independent of each other. Cool, so that means you have these tiny little yellow blocks that you need to position simultaneously to get into these tiny gray blocks. And it's just a very finicky process. Now, I am super clumsy. Like the first time I ever got onto rollerblades, a full 5 minutes into the process, I kind of went like, I fell over and broke my arm. Safe to say, my dexterity leaves something to be desired. So now I'm sitting there, fiddling with these little bits, and it's just not working out for me. I need a breather. So I sit back, and I look down at this engine thinking, this is a hell of a lot like the processing steps of Seeka. We have all of this raw data from the pipeline. We need to take that fuel and turn it into power. We need to process this data. Now, I am aware that in a real car, the engine drives the differential, but we're not building a real car, we're building a Lego car. And that's the order in which you build it, differential and then engine. Yeah, cool. The processing pipeline is broken up into 4 parts: document processing, video processing, web page processing, and table extraction. We can't keep it too neat, right? First up, document processing. This is where we take all of those raw documents that were downloaded, and we extract the text using text extraction and optical character recognition. And then we output that to a file. Now, we're pretty lenient with this one. We accept PDF, DocX, PowerPoint, Excel, JPEG, and more. So we even convert everything to PDF for you if that's what you need. Next up, video processing. This is pretty simple. We take the videos, we perform speech-to-text inference on it, and write that to file. We're slightly more restrictive with this one. We require only MP4 and MKV video encoding formats, and we have to convert MP4 into MKV. Next, web page processing. Now, this is specific to our crawler output. We actually take the crawler output and transform the format of those files into the same as the rest of the processing steps. Now, it is crucial that all of the processing files are in almost identical format so that the data is homogeneous and easy to use together later on. Lastly, table extraction. This is where we take PDF documents and the crawler output, and we extract tables, normal rows and columns tables. We need to do this because we actually treat tabular data a bit differently later on in the process. Now, because it only caters for PDF documents, it's useful to run document processing before this step so that everything is covered. These steps are like the McLaren engine because these parts can be used for different things, but to repurpose them will take some work. This is the V6 in the McLaren. Now, it's made up of the same basic building blocks as the flat six in the Porsche and the V8 in the Ferrari. But to turn one into the other will take some work. If you want your output in Skittles instead of JSON, that's going to take some work. If you want to process other video encoding formats or audio-only files, you're going to have to put in the work. So now, sitting on the floor, looking at the McLaren starting to take shape, it's an amazing feeling. Because now we're getting to the cool part. So it's pushing 10 p.m. and load shedding strikes. True story, right? So now we don't want to stop, so we MacGyver away for our phone torches, sand and shoes to shine over the construction, because this is where it gets cool. This is where it gets flashy. This is where we enhance the data. Data enhancement. This is the process by which we take all of that processed data and make it better. You can think about it like this. The data points are products, and currently, we only have the specifications, the color, the dimensions, the material, the literal stuff. Now, we're going to add the marketing material. This innovative storage vessel will revolutionize the way in which you experience your living space, transforming drab and dusty to sparkling and shiny, just like brand new. With built-in convenience features, you won't regret buying this bucket with wheels. Better. We're adding marketing to each data point so that it can bump itself up the list of search results. Now, this is the bodywork of the McLaren. It takes all of that power and energy from the previous steps, and it turns it into something useful, After all, we need some wheels to turn. The enhancement step is broken up into 3 parts: sentence generation, topic modeling, and named entity recognition. Sentence generation. This is where we break up the full body of text into logical bits of information, and then we place that into a knowledge matrix. This is useful because it helps us to surface connections between documents that are previously unknown. Topic modeling. This is where we train a model across our entire document set to identify groups of keywords that appear regularly. Now, the thing about these topics are they're just a list of keywords. So it could be something like electricity, blackouts, power cuts, anger. Now, we all know that that's the topic load shedding, but it's up to the humans to go and name the topics after they are generated. Next, we tag all of the documents with entities. We pass the model over using named entity recognition. We pull out names of entities, people, places, products, organizations, then tag all the docs with those. Now, this is also useful to detect trends in documents. For example, if we did a scrape of news websites over the past month, we'd see a large spike in the number of mentions of Queen Elizabeth II and King Charles III. These enhancement steps are like the bodywork because they serve a very specific purpose, and they work well for that. I mean, I guess you can build a blue and orange helicopter if you're really creative, but you're on your own with that one. But you can use them for something else. So, for example, if you do a scrape of all the documents about an insurance company, you can use the topic modeling model to identify groups that relate to life insurance, car insurance, and business insurance, and then group your documents accordingly. Or if you want to scrape news websites, you can identify which organizations are named and track sentiment about organizations in media over time. The last step in our pipeline is search. We use an open source-ish tool called Elasticsearch that allows you to freely search over your data. These are the stickers. These are built to work with the data that comes from the previous steps, and only those steps. They really only belong in one place. So once you have processed and enhanced the data, you index it into Elasticsearch, and then we provide 4 APIs for you to access it: search, answer, entities, and docs by entities. Now, our search works like this. You provide us with an English question. We then take that question and look at the full text of all the documents and decide which are useful. Then we see if there are any topics related to your question and bump up any documents related to that topic. Then we see if there are any entities related to your question and bump up anything related to the entities. Then we decide where in each document the relevant piece of information lies for you. So if we return a video, it'll be jumped to exactly the point where we think your answer lies. Or if it's a PDF, we'll highlight the relevant part for you. API uses a natural language generation model to generate an answer from your search results. Our Entities API grabs a list of all the entities that have been identified in your document set, along with how many documents are relevant for each, and then our Docs by Entities just grabs all of those documents. So now we have a whole car, right? We have the differential, the engine, the bodywork, the stickers. We went out, we bought a box, we shook it around a bit, and bam, there's a car. Well, clearly not. I said there are 4 parts to Seeka, and technically that's true for the pipeline itself, but you can't go out and buy a box and the car just appears. Frankly, that would suck. You need to build this thing. You need an assembly line. We use a free open source tool called Dagster. Now, Dagster is a lightweight orchestration engine that uses DAGs, directed acyclic graphs. That's just a fancy way of saying cascading series of events. We use Dagster to string together all of these processes into a pipeline that just runs for you. Much like the rest of the ecosystem, you provide us with a configuration file, your input, your output, and which folders you would like us to process. Dagster then takes that and generates all of the relevant tasks, some of which run in parallel, some of which are reliant on tasks finishing before. And that's it. Give your config file, press start, and off you go to have coffee for hours or days, depending on how large your data set is. So now we have the car, we've built the car. Now what? Yes. Anybody see that? Cool. Okay, so I might get logged out, fair warning. Yes. Okay, we have authentication implemented, but no refresh token. So if I leave it for a while, I get logged out, but it's all good now. So first things first, search. So we'll start with a generic question. So what I have here is a data set that I made for an Old Mutual demo, just some public service announcements and marketing videos. So we'll start with, when was Peter Moyo suspended? So now we go and search over all of that stuff. We get our results, and our top result is generated from our search results. So the board decided that in the circumstances, it was appropriate to suspend Mr. Moyo. This was announced on the 24th of May, 2019. Cool. So if we click through on the PDF document, that's the source, we actually see it highlighted for us. Okay, so I told you guys we treat tabular data a bit differently later on, so I'll show you that now. If I can find my mouse. Value of Old Mutual Limited Employee Trust. Fair warning, these definitely are pre-recorded questions. So below we have a table that was extracted from our documents, and this is why we treat it differently. We use a different question answering model to go across table content so that it can handle extracting rows instead of just sentences. So the value of the Old Mutual Limited Employee Trust is, I'm not great with numbers, so 25191,946.99. Cool. Now, videos. We want to show you that we do take you to the point in the video with your relevant question. So, by how much did the insurance margin rebound? Apparently, it rebounded to 6% in 2021 from negative 1.4% in the prior year. Let's see if that's what he says.
Across the majority of our businesses, our insurance margin rebounded to 6% in 2021 from minus 1.4% in the prior year. Strongly boosted.
And yes, that is exactly what he says at that point. Now, it might not seem that great to jump halfway through a less than 2-minute long video, but when you're looking at a 43-minute long meeting recording, it gets a lot more valuable. Now, I know this tab at the top here says topics, but these aren't actually the topics from the topic model. These are the entities. It's just the easily digestible word. So this is where we have our list of all of the entities. So let's go back to our friend Peter Moyo. 10 results related to him. And as we can see, there are, in fact, 10 results. So if we go and click through one of these, it should highlight the exact point where he is mentioned. And it does. Now, Everywhere in this document, it says NetBank. So we should be able to see this if we look for NetBank, right? So let's go back to our list. Look for NetBank. And there we have it, the same document. But instead of Peter Moyo being highlighted, sorry, every mention of NetBank is highlighted. And that's that. Now, in my final year of university, I was introduced to something called cybernetics. No, it's not some cool robot android stuff. It's actually very simple. It's the study of systems of communication and control. Input, action, output, feedback loops. When I was first introduced to cybernetics, I was intrigued by its simplicity, the study of systems in isolation, circular systems, and we see them everywhere, from conversations to thermal body regulation to microeconomic cycles. Supply drives demand, drives supply, you get the gist. It's great, but let's for a second focus on that example of thermal body regulation. Your body feels hot. Signals get sent along your nervous system telling you to sweat. You sweat, your body cools down, signals get sent, and your body's like, cool, stop sweating now. What a beautiful system. One thing though, I don't know about you, but if I feel hot, I don't wait around for my body to turn my sweat glands on and off. That's just unpleasant. I open a window or turn on a fan, or if I'm desperate, I jump in a pool. So what I have done is by observing the system, I have decided to disrupt it. This is the area of study called second-order cybernetics, the inclusion of the observer of a system as a part of the system. You can think about it like this. When we build applications, there's the way of using it as designed, and a perfect user won't disrupt this flow. I don't know about you, but we don't write applications for perfect users. We write for those snowflakes that have to push that button before the service call completes, or the guys that go, how long can I make my nickname? Or malicious users, can I inject my own code here and send everyone's passwords to me? We take our users into account when we design our systems. We build our systems to be disrupted because we allow them to be disrupted. We've learned from the users how this can happen. If nothing else, this is a pretty good takeaway from today. Read up on second-order cybernetics. It's really cool to look at systems as being unique based on the users. And if nothing else, it means you can blame all of your bugs on the users. So that's great. Now, the feedback loop is a very important concept in machine learning. Models need to learn, hence machine learning, to get better. And Seeka isn't any different. We have feedback loops. Our topic modeling model gets updated when your data shifts over time. We allow for user-specific information to get sent through with the APIs to narrow down search results, not personally identifiable information, more like job role. We even have user tracking implemented. But if you know data and user tracking, you know it's very useful if you have users. This is where you all come in. If you find yourself sitting around thinking, damn, I wish I didn't have to sift through this large pile of documents or some other comically vague scenario, think about what Seeka can do for you. Because what you can do for Seeka is help us feed back into the system to make it better. Help us to bring up the results that are more relevant. Help us to be more accurate. We aren't born just knowing how to code. Well, at least I wasn't. We had to spend time on Stack Overflow and pull requests and peer reviews, and we had to take the feedback to be better. Help us by giving us feedback to make Seeka better. Remember that scenario in the beginning? you're late for work, you're blocked out of your account, you can't get into this meeting and it's just not going your way. We can't fix traffic. We can't stop the client from blocking your account. We can't unblock it any faster. We definitely can't bring you your coffee. But what we can do is take one thing off your plate. You don't need to play hide and seek with your data anymore. You can just find it. Thank you. I don't know if anybody wants to ask something. We have a question.
Hello.
Hi.
My name is Leonard. So we've been recently recommended to use Seeka on one of our projects. And in this case, it's quite a different use case from what you described here. And I was curious to hear your thoughts on it as well.
Mm-hmm.
So we have a chatbot and a human-to-human switch over. So the idea then is, if the chatbot can't answer the question, we switch over to the human, and then the human answers the question. But now, could it be possible to apply Seeka to make the chatbot smarter by looking at the conversations that have been had to feed that back into the chatbot feedback loop, almost like you mentioned now?
So it's definitely useful to have Seeka to pull the relevant information out. We don't as yet have context tracking because we didn't build a chatbot, but it is something that can be used in the future as an extra signal. But it's definitely useful to pull relevant information to bring up the right result. If your chatbot doesn't do that right, which most don't.
No.
Yeah.
All right, thank you.
Everyone in the front?
Hi. So what is Seeka? Is it something like Vanguard that BBD has developed and sells to the clients and we enhance it? Is it a tool that we can use as selling something when we're at the client?
Yes, definitely. But you don't have to take all of it. You can take the part that's relevant to you, which is why we built it that way. So if you find yourself in a situation like you need to track trends about something, you can use it. But if you want the out-of-the-box solution, the whole thing, just index data, search it, it's great for that as well.
Okay. Thank you.
Hi. Just a small question. Regarding your text recognition, does that only work when you're using scanned typed documents, or can you scan handwritten documents?
All right. Because we use optical character recognition, handwritten works as well.
Okay.
As long as it's not doctor's handwriting.
I was
All
about to
right,
say.
let's be reasonable here.
Okay, cool.
Cool. With the OCR, let's say you've got an image-based PDF, but you've got tables and stuff in it. Does it actually convert those image-based PDFs to text-based PDF for indexing later, or does it skip the PDFs in the conversions?
So if it's a PDF that's
Image-based.
Image-based.
Pretty much just pictures inside it. Most scans and stuff end up doing that.
oh, it's just going to extract the text and write those to file and just leave it as a PDF.
Okay, cool.
Yeah.
Maybe a silly question, but how can we help you help us help you? Where do you go?
Well, first, it boils down to first you have to identify a need. Because if no need exists, you can't make a client need something. You can't sell something you might need in the future. So look around and firstly, familiarize yourself with what the contents of it are. And if you identify oh, I wish I could do this, go, hey, I know what you can do, kind of thing. So get familiar, chat to me, I can take you through it, show you how it works. And yeah, just keep us in mind.
Hi there. I'd just like to check, is there any protections there for sort of like unauthorized data access, you know, having someone search for data which they actually shouldn't be able to see in the first place?
Or just all?
You know, say they have access to your knowledge base, but you have a whole bunch of index information there that might be privileged.
Yeah.
Is that sort of thing secured as well out of the box?
We'll have to implement the auth specific per index, but we've done it before that you just can't access an index that you don't need. Yeah.
So it's not a question to Tiané, but an answer to Katie. I think one of the reasons for today's session is, one, to make people aware of Seeka within the organization, because it is something that we've built homegrown. It's something that, you know, it's ours and we can sell. And so people aren't aware of what it can do and what its capabilities are. But I think also when those that have been aware of Seeka, they've tried to sell the Seeka as its entire concept. And what we're trying to show here is it's made up of a bunch of different modules that could be more relevant to your situation than just the search capabilities. So if you think about all the modeling and topic recognition, the image, the voice to text translations and stuff that we do, you know, those can be applied in your use cases without actually having to use the search function. So today is about making you aware of Seeka, making you aware of the components, and then trying to relate that to scenarios that you experience within your clients.
Thank you, Marius. I appreciate that. Unfortunately, you're going to have to come talk to me afterwards because we're out of time.
Sorry, Tiané, one last question online.
Okay.
How much would it cost to use the system?
Talk to Russell.